All right, happy Monday, everybody. Today we're going to continue studying about the instantaneous rate of change. And we remember as we begin this study that the only thing constant in life is change. And that's what we measure a lot of in mathematics is different types of change. We started the year learning about constant rate of change, which was the linear function. Then we went into recently the average rate of change, which is when we have a graph that is a curve and not a straight line. So we're going to look for the average rate of change, which is between any 2 points. And that line that we draw between those 2 points is called the secant line. And we simply use the slope formula to find what the rate of change is on that interval. Then we have the instantaneous rate of change that we started Friday, which is where we have a series of successive secant lines. So we see we have PD, PC, PB, and PA. And all of these lines are drawn over different intervals that are getting closer and closer and closer to point P. And by the time the secant line gets to point P, it becomes what we call a tangent line. And the slope of that tangent line is going to be what we call the instantaneous rate of change. So the secant line touches 2 points. The tangent line only touches 1 point. So again, the instantaneous rate of change is a measure of velocity at a moment in time. So if you're out driving on the road, you have an average speed that you drive. But when the state trooper uses her radar gun to clock your speed, it's at 1 moment in time. It's an instantaneous rate of change. It's velocity at a moment in time. Okay? So let's look at this first problem that we'll do together. It says Paul threw a tennis ball straight into the air. The relationship between the height f of x and the distance with respect to the time is given in the following function. F of x equals negative 16x squared plus 32x plus 6. Find the instantaneous velocity of the ball at 1 second using the following intervals. All right, then you're going to do just like Friday, write the equation of the tangent line and graph the function and the tangent line using Desmos, rounding all your answers to the 10th position. All right, so just like on Friday, I made you a calculator that you can use for this on Google Sheets. So we're simply going to begin by typing our intervals. And you'll notice again, every interval begins at 1 because that's what we are trying to find the instantaneous rate of change. And these intervals are all getting closer and closer to 1. That's what these decimal numbers mean. They're just getting smaller in value and closer and closer and closer to 1. So we're simply closing the interval. Okay? And so over here in both the Y2 and the Y2 cells, again, I've programmed that function in there to do the work for you. And then, of course, the rate of change is set up to do Y2 minus y1 divided by x2 minus x1. So you'll notice here that our rate of change very steadily approached 0. Okay? So just like on Friday, what you're going to use for your point slope formula, oops, I didn't want to highlight that one. I want to highlight this one. What you're going to use for that point slope formula is your rate of change and then your last y1 that you have here and your last x1 that you have here. And that's what we're going to use to write the equation of the tangent line and then graph that tangent line along with the function. So I come over here and I have y minus y1 equals m times x minus x1. Okay? So I know that my y1 is going to be 22. Zero. All right, so anything 0 multiplied by anything is 0 when I distribute that. So I have here y minus 22 equals 0, but I need to isolate the variable y by itself. So I'm going to add 22 to both sides, and I get an answer of y equals 22. So that means the equation of my tangent line is y equals 22. So I would come over here to Desmos, and I'm going to graph the function, which is f of x equals the negative 16x squared plus 32x plus 6. And then my other answer, my y equals 22. There's my tangent line. And so if I look at it, the slope of my tangent line was 0. And this is a straight horizontal line, which means it's a zero slope line. So what that tells me is that when the ball reaches right up here, which we know from studying parabolas is my vertex of the parabola, that it's actually not moving at all because it's making the turn and getting ready to drop down. So you would just have as your rate of change for this problem 0. All right, so that's what I've got for you today. So there's 4 more problems you can do. Go ahead, use the calculator, do just like you did before. Screenshot everything to the Google Doc. Make sure you include your work as far as taking a picture of it. And if you didn't already do so, watch the video with Professor Dave. It's really good and will give you more of a conceptual understanding about this topic. All right, have a great day, everybody.